There we go. So I want to talk today about a couple CVs that came out, I think around November or maybe October last year. And I did an initial kind of splash, but then fairly quickly where all the hype was taken by Log4j. But I think these things are really fascinating, not necessarily from impact perspective, because ultimately the impact is not that high, but from just how similar problems come up all the time. Like I remember vividly listening to a talk that I think Roberto from WebSec was doing at Besides Vancouver, probably 2017. So it's quite a while ago. And one of the things he was talking about for like creating phishing links that are believable was using essentially very similar techniques with Unicode control characters. And this is kind of same topic in a different context, and you have a whole new set of problems. So I'm assuming everybody sees my slides. If no, shout out. So what I'll start with is basically what is the root cause of both of these issues. And I've got a couple of demos that kind of show how both of these work. But basically the first thing to keep in mind is Unicode is a very complex thing. And one of the pieces of that complexity is these Unicode code control characters that essentially control how the text is displayed and or interpreted. And probably the most famous ones are the control characters that control text direction. So imagine you need to write something in a language that's like read right to left instead of left to right. So you are able to do that. And more importantly, you are able to mix in the same text, mix the languages of like both styles and have them displayed properly together. So it's not like a per document setting, it's per piece of text setting. These control characters themselves often don't have visual representations. You looking at the text, you don't actually see that those control characters have been used. Like there's no visual indication that they're there. And so among the control characters, also things like tabs. So basically things that control how the text is displayed. And the issues that I'm going to talk about today that are stemming from control characters of the text directional control characters, and there's a whole set of them, but they basically just control the direction of the text, and they apply to different parts of the line or parts of the text. So there's ones that basically can apply within a small piece of the line. There's parts that basically apply till the end of the line or need to be reset to kind of go back to the initial direction, et cetera, et cetera. So this is the full list of them. So there's like left to right embedding, right to left embedding, et cetera, et cetera. And the first, I'll quickly check the XXD, all the things. Yes, right. I've got a couple demos, and the first one is just to demonstrate this direction control characters. And to do that, I've got a simple text file. I'm going to open it in an editor that supports Unicode. And you see that we see the string of DefCon604 in here. But if I do XXD or just even cat, the same file, demo1.txt, this is what I get in the terminal. And to understand what's happening is if I open it in hex editor or VI, it's going to show me the control character. You see that in front here, there's some control characters that basically say, hey, when this text is displayed, should be displayed written right to left. And so this string, when displayed, turns into this string. Important piece here is that the file still says this. This is what's in the file. But when you, meaning that human that is interpreting the file, is looking at it, this is how they see it. And that's kind of the semantical differences, quite important, and it's going to be more obvious in the next demo. So the next demo is one of those CVEs that was disclosed by the team. It was a team of researchers, and I'll give you a couple links to kind of find more information about this. So this is the first one, CVE 2021, whatever, so sometime last year. And this has to do with basically using these directional characters to adjust the interpretation of the source code. So this is a demo file. I'm going to compile that first to show you what's happening. So this is the source file, and even to some extent, looking at this, you can figure out something weird is going on, because just based on the coloring of the source code, you see that this doesn't look the same as this, but just if I read it as is, here's the comment, here's an if statement. This should only be executed if this if statement is true, which it's not. So if I just read it as is, as displayed, I should not see, when I run it, I should not see this bingo, you have access. Whereas when I actually run it, this was demo 2, I do see that string. And so the trick here is that within the source file, this text with the if statement, it's actually inside the comment, as is this closing bracket. It's just, but the text file is using those directional control characters to present on the screen when I view it, this text differently. So again, if I open it in, in VI, you see here's the control character. This is the actual text, and the if statement is inside inside the comment. Conceptually, what's happening here is different interpretation of the source code when a person looks at it in the editor versus how compiler sees it, because compiler doesn't care about those control characters. Most compilers, at least, used to just ignore them. They don't exist, basically. They don't care about them. They don't care how the text is displayed. They care like what's in there. And so when I'm looking at this as a human, I expect this to be part of the code, but in effect, it's not. And so this essentially is a way potentially to conceal malicious code in the source code files and kind of sneak in malicious code into like public libraries or anywhere where you can do a PR, a pull request, or something like that. Quickly checking questions. So most IDs honor those characters. Then most IDs do. I've also checked this in, and I haven't checked like all of them. Oops, sorry. But I have checked Visual Studio Code, and the update that came out right after the CVEs were announced. It was honoring them, but it was basically displaying warnings, so giving you an indication of the control characters in the source code. So they've basically changed the behavior. They used to just ignore them, but now there is some indication that you can get what's happening. SAST should catch this, but again, so this is a cause and effect, in a sense, relationship mark. So a lot of the SASTs now will catch this. A lot of the SASTs before CVE was published, not necessarily so. And I'll talk a little bit about like what are the vendors doing about this in just a bit. So good rule should be able to look for those characters, yeah. And it's a blacklist, and sometimes it will fork the rule. Why would they not show these as literal characters? So, and yeah, they would, but like if you follow, like, because IDEs are basically editors, text editors with some additional functionality. And text editor that supports UTF is, or Unicode in general, I mean, is supposed to follow these characters, and majority of just the text editors don't even bother to tell you that there's control characters in there. All right, so this was the first CVE, and probably the main one that was interesting and kind of novel. There was another one that's listed in the same website that has to do with homoglyphs. And homoglyphs are basically Unicode. Again, we're talking about Unicode. Everything is about Unicode. Homoglyphs are different Unicode characters that look the same. And the perfect example that I, for example, understand really well is you can have different alphabets, like let's say English and Cyrillic, or Latin and Cyrillic. And there's a lot of the letters that look absolutely the same. There's a big intersection there, like for example, A or E or C. There's basically very similarly, if not exactly same looking letter across those different character sets, but it's a different character. So it looks the same, but it's a different character. And you could theoretically use this for various things. First is, for example, you can use it to, again, kind of the phishing scenario. You can come up with a domain name that uses international characters, and it might look the same as a valid domain name, but actually in reality be different. So browsers have dealt with that for quite a while now. Basically, they convert that international domain name to sort of authoritative representation with like IDN, whatever. I don't know if you've ever seen those kind of internationalized domain names, but you can also use this in the source code type scenario. And so this is my third demo, and for this I'll need to open two source files. So I've got this example here. Sorry, I'll start with a good one. So here's two different files that look absolutely the same. Like visually, you cannot tell any difference. And so what we're going to do is try to run both of them. So again, in the file, what's happening, there's a dependency we call check access. If it's true, it should print bingo. If it's false, it should print you shall not pass. So running the first one, demo 3, good. It tells us you shall not pass. Running the second one, it says bingo. So something's wrong here, or something's happening, something is interesting happening here. So the trick here is that this dependency, the class name, in the bad example contains one of those internationalized characters. So this call and this call refer to completely different classes, completely different source code files. So, and you can see even in the tree here, there's two files that look like they're named the same, but they're actually different. So here's one, and I can't remember which one is which, so bear with me. So this is one that returns false. So this is probably the good one. And this is a different one that returns true. And again, like from this code, from the file name, like it's hard to see that something's different or something's wrong, but it's essentially one of these, either an E or an O, and I can't even remember. Oh, it's probably this one. It even has a different color. Is an internationalized homoglyph. And so potentially this could be another way to kind of sneak in changes into the source code that might not necessarily be flagged in a code review type scenario. All right. That's basically it. That's the explanation of the CVEs, and that's my demos. And I guess my question is, and this is what I want to put out for discussion, is so what are essentially the implications potentially? And I'll mention a couple more things. So I'll post a link to the initial advisory, the website that the researchers created. There's and another link that I'll post is so one of the best advisories that I've seen from like different vendors was from the compiler for Rust language. And basically starting when they're fixed to this, like they said this is a vulnerability in the compiler itself, and their fix to this CVE was that they're basically throwing errors if they see any sort of Unicode control characters in the source code. So basically, you can safely compile any file, and the compiler guarantees that if you're looking at the file in the editor, it looks the same as how compiler will interpret it. Probably doesn't have with the homoglyph stuff, and so that's still a question to keep in mind.
Can you try Dana's command there, that diff command, and see what it shows?
Yeah, sure. Let's try that.
I personally do not.
You gotta show your screen again. Yeah, thanks.
So what are we diffing? The
demo 3, good and bad.
Yeah.
Yeah, interesting.
So this is different. The class name is different. I mean, it shows that they're like, it's not obvious why, but it shows that they're different.
Yeah, I was wondering if diff would actually echo out the characters.
I think that also depends on your like language settings. So I wonder if that's what's happening here. I know I'll have to see, like my console is set to Unicode, which is a common, like this is a default installation of Ubuntu with a couple added tools.
Yeah.
So I wonder if like changing your language, to me, it should have changed the behavior, because like, well, to me, this basically says interpret symbols byte by byte and like not going to that Unicode crazy shit.
Yeah. What's interesting is I'm thinking like from a code analysis point of view, if someone was just going in and put those characters in the middle of an existing stream, the diff, you won't see that. Like I'm wondering even if the git diff would show it, so you could at least see it. Peer review wouldn't catch that.
Right.
Now, reality is anyone who's going to put those characters in is probably going to put some other stuff as well. Like your first example where you were showing, the blocks of code being manipulated. They're going to see that. They're going to be able to, but that's interesting. I posted a Sonar source. Their ruling is just for those explicit characters. So they're actually blocking on those.
GitHub started, like, I can't remember how, but they started highlighting the Unicode control characters in the diffs and pull requests and whatnot.
Oh, good.
All right. What questions did I miss? Yeah, so the Y was colored differently, and yeah, that was the letter that was changed. It was at the end because I think Adam, like once Adam would encounter that internationalized letter, everything after that in the same identifier was also colored differently. So I think that's why I put it at the end. It's a little bit more sneaky that way.
I don't understand why an IDE would be behaving like a word processor and ignoring something that's so critical, that's like as valid as any other code character.
Because managers are coding now. It needs to be pretty.
I think it's probably happening in the name of being universal, that you can accept more languages by doing Unicode, and you have users from around the world, and then there's unintended consequences of that.
I think that's exactly it. So Mark, imagine I'm a coder and I want to put a comment or even like part of the string, Unicode string with like right to left writing. So that when I said that Rust language basically prohibits those directional control characters, they prohibit directional control characters in the code, like the code that's being executed, but not in comments and not in strings. So that piece is still a valid use case. And ultimately in there, you want to see that it, like when you look at the source code, you want to see the text displayed correctly. So I think there is valid use case, but it's a combination of that and like human view versus compiler view that creates a problem. Yeah, Sia, thanks. That's exactly the internationalized domain name.
Yeah, but interestingly, in a chat box, it's not showing that the original language of that. I'm not sure what you can see, but here I can see is some character. It's a Unicode character instead of what I type in the question.
So here's the thing though, like you can't put a link in like email or a page that will have the international characters. But when you click on the link and when the browser shows you in the URL bar where you went, it will always display a name like that. And that's specifically to kind of combat phishing attacks.
Interesting.
And like when you need to request a certificate, like this is basically the canonical name that you're going to use for any sort of plumbing.
Makes sense, yeah.